Now let's talk about the generation of waves. All of us, we do one mistake. We know this format and we just mug it up like this is generated by atrial depolarization. This is the ventricular depolarization, but this is the repolarization of the ventricles. But we should not study like this because the SA node is generating it and they are spreading across the various places in the heart. They are creating these waves. So we should understand how these waves are created. Once you understand how these waves are created and which direction they go, we will understand the reasons for various questions. For example, I will ask you one question. If you answer it already, it is very good. The T wave is a repolarization wave. Repolarization, all of us know, it is a changing back to negative. Why it is showing a positive deflection here? That is one question to be answered. Then see this QRS complex. The Q wave and the S wave, even though they are depolarization waves, because QRS complex is a ventricular depolarization, but still Q and S is showing a negative deflection. If you know already the answers for this, it is very good, but we'll try to enhance it, establish the concept why this is happening like this. There depolarization, but it is showing negative. Here a repolarization this wave is showing a positive. Even in the classical lead, that is the lead 2. So the basic diagram, this diagram comes from the lead 2. Now tell me, in lead 2, which arm is positive, which arm is negative? In lead 2, the right arm is negative and left foot will be positive. So that's why we have drawn here. Here you can see in all the diagrams, we are representing the lead 2 only because this is in the direction of the heart. So once you understand lead 2, the rest of the leads are easy. So a negative is there and positive is here. So let's start with the first thing. First, who is the dominant pacemaker? The SA node. The SA node is going to fire now. Finally, the SA node is going to fire. When the SA node fires, what will happen? These will be conducted through the internodal fibers to the AV node. Not only that, the atria also will go for depolarization. So the atria will get the positive charges, depolarization. So many books write voltage, current and various things, but let's try to understand through the depolarization only. So what will happen? Now they are generating minute potentials in every place. So these potential will generate some minute waves. They will be generating some minute waves like this in this direction. In whatever direction it is getting depolarized, now it is getting depolarized like this. So they are generating a wave like this. So these small things are called as instantaneous vectors. The name for this is instantaneous vector. Why it is called instantaneous vector? Because it is produced in that particular instant. Do you think the voltmeter will record all the instantaneous vector? No, it will not record all the instantaneous vector. What it does is it combines all these instantaneous vectors and whichever is the final outcome, that will be recorded by the voltmeter. So whichever is the final outcome, that will be recorded by the voltmeter. And the final outcome is called as mean vector. And this mean vector will have both amplitude as well as direction. Amplitude and direction. So now let's go back and see what will be the direction. The SA node is firing like this and it is going spreading like this. So what will happen? This SA node firing will ultimately go in this direction and the instantaneous mean vector will be in this direction. So it is a depolarization wave. Now tell me, depolarization is going towards a positive terminal. As you can see here, it is going toward a positive terminal. Now tell me what will be the deflection? The deflection will be positive because we saw positive ions going towards positive. It is a positive deflection. So the deflection is going to be positive. And tell me, the musculature of atria is big or small in comparison with ventricle? It is smaller. So the amplitude will be lesser. The amplitude depends upon the musculature. So coming to this atrial depolarization. So this atrial depolarization, what wave is created? The P wave is created and its deflection is positive because positive ions are going to positive and its deflection amplitude is also low because its musculature is low. So the P wave is generated. Now we are done with our P wave. Now from the SA node, coming to the second activity, from the SA node, it has reached the AV node. An AV node, what is the main function? It acts like a gatekeeper. It keeps the potential within itself for some seconds, 90 milliseconds. So this activity is called as AV nodal delay. During the AV nodal delay, do you think it is producing any pattern of generation of electrical activity, it is very, very minute. It will not be picked up by the voltmeter because the conduction is happening inside the AV node, which is very, very mild. So obviously, no conduction, no potentials are being produced that can be recorded. So what will happen? It will give you a flat line. It is going to give a flat line. What is this segment? So flat lines are called as segments and waves are the deflections and intervals include the segment and the wave. So this flat line is nothing but our PR segment. Some of the elites does not record the Q complex. That's why it is called PR segment. You can ask me why Q wave is the one which is going to come next, but still it is called PR segment. Why? Because the Q wave is absent in some of the ECGs. PR segment. So they have given this name. Now we are done with 2. Now from here, where it will go? It will go to the bundle of His and then the Purkinje fibers. So let's go to the ventricles now. So coming to the third activity, that is ventricular depolarization. Ventricle is going to get depolarization. But ventricular depolarization happens in 3 different phases. It does not happen in one go. It happens in 3 different phases. That is the reason we have 3 waves, Q, R and S. So let's understand why it happens. The first wave, what it is going to do is, the bundle of His is like this, the bundle of His is like this, and it is giving the right and left bundle branch. It is giving the bundle branch. From the this side, left side, what will happen is the fibers will go and give the impulses like this. So it is now depolarizing only one little portion that is called as the interventricular septum. It is just depolarizing the interventricular septum. And now tell me, the depolarization is happening like this, backwards. Can you see? The arrows are going like this because the direction of fibers is like this. So it will happen like this. Now what is happening? The positive ions are moving in which direction? The positive ions are going like this. What is the potential we have here on this direction? We have the negative. So positive ions are going towards the negative. What is going to be the deflection? The deflection is going to be negative because opposite side it is moving. So first phase, that is 3A, ventricular depolarization, starting phase is the septal, I can say septal depolarization. The entire ventricular depolarization does not happen in one go. And what will happen? It is giving a negative deflection. It is giving a negative deflection. Why it is negative? Because the positive ions are going towards a negative terminal. And the deflection will be small. Negative. Why it is small? Because now we are depolarizing only the septum. Septum is a small musculature. Negative and small. What is this wave called as? Q wave. Now that is the reason why the Q wave is negative. Even though it is a depolarization wave, it is moving in an opposite direction. That is why it is causing a negative deflection. Now coming to the second activity. Now what will happen? Now fibers, Purkinje fibers are spread into the entire ventricular musculature. All of them it is spread. And what will happen? Many instantaneous vector will be produced. And instantaneous vector will be produced by the right ventricle also. Don't think it is only produced by the left ventricle. It will be produced by all of them. But now tell me, the final mean vector will be towards the left side or right side. It will always be towards the left side in a normal person. Why? Because the left musculature is very, very strong. It is pumping against the aorta. So the muscularity keeps on increasing, keeps on hypertrophies. And finally, the deflection is more towards the left side. That is the mean vector will be towards the left side, mean vector. This is called as major ventricular depolarization. This is called as major ventricular depolarization. And this major ventricular depolarization is a positive wave and it is going in which direction? It is going in a positive direction. So what will be our deflection? Now the theme becomes easy. Our deflection will be positive and it is done with the help of sodium ions. So it will be very, very fast. Like the amplitude will be very, very fast and it is a huge in size because of the R wave and the musculature. It is done with the help of sodium channels. So it is faster to open and faster to close. And that's why the R wave is steep. The R wave is very steep. Now we are done with the Q wave and R wave. Now coming to the S wave. How does it happen? So finally the fibers reaches here. It has depolarized these parts as well as the septum. Everything it has depolarized. Now finally the fibers are giving it to the basal region. The fibers are giving the impulses to the basal region. What happens in the basal region? The fibers are going like this. See, it is all dependent on the fiber direction. And the fibers are depolarizing in this direction. It is moving like this. Now positive is moving towards a negative terminal. What will be the deflection? The deflection will be negative. So next thing is, it is the basal depolarization. Basal depolarization. And what is the type of wave we are expecting? We are expecting a negative wave. Why? Because it is going in opposite direction. So this is our S wave. Negative, and basal region is also very small musculature is there, so it is small. So this is the waveform. Now what happens? Now ventricular septum is depolarized, ventricular major ventricle is depolarized, then the basal region is also depolarized. When all are depolarized, all of ventricles depolarized, what will happen? Do you think any current is passing through now? Now there is no change in ions. Whenever there is a change in ions or change in current only, the voltmeter will pick up. Now nothing is happening. So it will give us a flat line. This was the fifth rule we were studying. It will give us a flat line. So flat line is there. What is this flat line? ST segment. So it is flat lines are called as ST segment. Then what happens during the next phase? Now everything is depolarized. The repolarization has to begin. So what happens? The fifth activity, it is called as ventricular repolarization. Ventricular repolarization. And this ventricular repolarization, it starts from apex to base. See the wonderful nature of it. It is starting from apex to the base. That is one point to be noted. And it also starts from the epicardium to endocardium. Endocardium. So first thing is it is starting from the apex to base, and from the outer surface it is going inward. So this repolarization is a negative potential. Now all of them are moving like this, moving towards this. Moving towards what arm? Right arm. So right arm is already negative. Now tell me, the negative terminal, negative potentials, whenever they move towards the negative terminal, what is the kind of deflection we expect? We expect a positive deflection. We expect a positive deflection like this. And what is this wave? This wave is nothing but a T wave. And T wave, whenever you see, it is not going to the amplitude of R wave. R wave is produced by the ventricular muscle. T wave is also produced by the ventricular muscle. But why the height is not reached? Because the repolarization is caused by the potassium channels, and they are slower to open, slower to close. So this T wave is like a spread over time. It is spread over time. Spread over time. Whereas the R wave comes like immediate amplitude like this. The amplitude is high, but the same wave like the for musculature is spread over time in the T wave. The distance covered, if you calculate and average it out, everything will be same for, because both are for the ventricles. But here it is slow, so it is spread over the time, and the wave is flat. But little amplitude is better than the P wave because the musculature is huge. So this is the reason for the entire wave generation. And we missed one event. We saw the atrial depolarization, ventricular depolarization, ventricular repolarization. What happens? What is the wave produced by atrial repolarization? Atria also have to repolarize, but it is not producing any wave. What is the reason behind it? Because when atria is repolarizing, what is happening in the ventricle? The ventricle is depolarizing. Ventricular depolarization is a dominant activity, and it subsides or downs the activity of the atria. Like the wave potentials are not recorded from the atria, because the major activity of the ventricle is going during the atrial repolarization phase. So we are able to only record the ventricular repolarization and not the atrial, ventricular depolarization and not the atrial repolarization. So these are the most important points in ECG. Now coming to the waves, we will write them all in one go. P wave is, now you tell me, P wave is positive and it is showing a positive deflection. It is due to the atrial depolarization. It is due to the atrial depolarization. Then PR segment, it is due to the AV nodal delay. Now QRS complex, please don't say that it is due to ventricular depolarization. We are going to say it very specifically. Q wave is due to septal depolarization. Then R wave is due to major ventricular depolarization. Then S wave is due to the basal depolarization. So all of them are ventricular depolarization, but we have to know their individual specific reasons for it. Then what is the segment? There is another segment, ST segment. This ST segment is the one which is happening when all ventricular muscles are depolarized. If the ventricles, all of them are depolarized, then there will be a flat line only. All ventricles are depolarized. Then finally coming to the T wave, it is the ventricular repolarization. Here the negative ions are moving towards the negative terminal, so it is giving a positive deflection, and here it is spread over time. So these are the waves which is produced by the classical ECG.